Good morning, everyone. Today I will present our paper titled Optimizing Classic Sentiment Analysis with Few Short Learning, a SETFIT and Transformers based on Ensemble framework. This study focuses on Vietnamese text classification, especially in few low-resolution settings. Our goal is to improve classification performance when we only have a small number of label examples. In this work, we combine SETFIT with a few short-learning models with a stacking example framework using three transformer models: per-bird, backward, and free-bird. The main problem is that many NLP models need a large amount of its label data. However, Vietnamese is still low-visual language, so collecting and labeling data can be expensive and time-consuming. To solve this problem, we use few short learning. Instead of training with a large, very large dataset, we train models with only a small number of examples. The key idea of this paper is also about model diversity. A stronger model is not always enough. Sometimes a weaker model can still have if it makes different mistakes. Additional deep learning often needs thousands or even millions of label samples. This is difficult for Vietnamese NLP tasks. Feature learning is different. It tries to learn from only a few examples, such as N1, N5, or N20 examples per class. This is useful because it is closer to real-world situations. In many processes, we do not have enough label data, but we still need a good model. In this study, we use three Vietnamese transformer models. The first model is Herbert. It is strong for Vietnamese text class processing and usually gives a good performance. The second model is Bradford. It is useful for understanding system and meaning and can be flexible with Vietnamese text. The third model is Freebird. It is weaker as a single classifier, but it has a different learner behavior. This difference is very important because the example can benefit from models that do not think in the same way. This slide shows the first level of our framework. First, we start with a small dataset using and 1 and 5 or 20 examples. Then separately as system pairs. These pairs have the model learn which sentences are semantically similar or different. After that, it transforms a model in Python. Finally, the models produce embeddings and prediction for classification. In simple words, SETFIT has transformers learn better very limited label data. The second level of framework is stacking. Stacking is not simple voting. It does not search through the most common answer. Instead, it uses another model called meta-learner to make the final decision. In our study, the meta-learner is logistic regression. It receives the prediction from Herbert, Bradford, and Vibert. The meta-learning learn which path is more reliable in different situations. So it works like a judge that combines the strengths of one model. About dataset, we use the IUT-VSFG Vietnamese student feedback dataset. This dataset contains around 16,000 Vietnamese sentences. There are two tasks. The first task is sentiment analysis. The model predicts whether the feedback is positive, negative, or neutral. The second task is topic classification. The model reads the topic of the feedback, such as lecturer, curriculum, facility, or order. Sentiment analysis is easier because the labels are more rigid. The topic classification is harder because its meanings can overlap. For sentiment analysis, the best result is achieved by combining verbs and buffers. This combination reaches an F1 score of 0.81 at N20. However, we add the verbs, the score drops slightly to 1.0.81. This result shows that more models do not always mean better performance. For the simpler task like sentiment analysis, the stronger models already cover most of the useful information. In this case, people add more noise than benefit. For a perfect classification, the result is different. The best result comes from combining on three models: Herbert, Bradford, and Weber. This example reaches an F1 score of 0.78 at 20 and 20. Although Weber is weak when used alone, it becomes useful inside the ensemble because topic classification has more complex and semantic boundaries. Rebus provides a different view. This helps the meta-learner correct some mistakes from the stronger models. To explain this result, we analyze the model collaboration. The purpose and buffer have high agreement with the collaboration of 0.78. This means they often make similar revision, but also means they may make similar mistakes. People have lower correlation with other models. This means if revisions are different, in ensemble learning, difference can be valuable. A weaker but different model can have ensemble fit roles that strong models share. This slide is one example. This sentence is ấn tượng nhất là thầy dạy không cần máy chiếu. The correct label is literal. However, Herbert and Bradford treated facility for properly because they focus on work procedure. Weber treated the correct label literal because it focuses on work picture. This means show why model diversity is useful. A smaller or weaker model can still catch a different semantic signal. From these results, we should get a task-aware example design for simple tasks such as sentiment classification. It is better to combine the strongest models and remove weak models if they add noise. For the complex tasks such as topic classification, the model diversity becomes more important. In this case, even a weaker model can improve the final result if it gives a different perspective. So, the best example depends on the type of task. There are no one fit formula for all NLP problems. Experiments are run on Google Colab using MGVR Tesla T4 GPU. For the SETFIT training, we use the batch size 32 file epochs and Adam optimization and frost entropy loss to check if the improvement is reliable. We use statistical tests using ANOVA and Turkey SSD. The result with p-value smaller than 1.0.05 means the improvement is statistically meaningful, but just random noise. The study still has some limits, but the experiment focused on vitamin tests, So future work can be tested on the framework on multilingual models such as Amber or XLM. Robusta second, using three transformer models may cost more in the real development, so the future resource study speed, memory, and cost efficiency. Third, other ensemble methods can be explored, such as boosting prototypical networks. In the conclusion, the paper showed that SETFIT and stacking can improve Vietnamese text classification in low data setting. The first key message is that the feature learning is useful when label data is limited. The second key message that SETFIT helps the transformer models learn to better semantic presentation from small data. The second and the most important message is that diversity can more important than broad model traits. For simple tasks, strong models can be enough, but for the complex sentiment tasks, a weaker but different model can help the ensemble become more robust. Thanks for listening. I'm happy to answer your question.